Hello and welcome to the second part of our Qlik Capability API series. In this course, we're going to dive deeper into the Capability APIs and look at the different ways that we can work with lists and tables of data. And in addition, take a look at how we can leverage bookmarks within a mashup. One of the most powerful features of the Capability APIs is the ability to leverage existing visualizations and render them in a web app or mashup without having to write a lot of code. If, as a developer, you wanted to complement the Qlik visualizations with a custom one of your own, or perhaps if you want to leverage an external chart where someone else has done all of the hard work, you will still need to do one thing for sure: fetching data. This can be achieved through the use of several methods made available to us by the App API, which, as a quick reminder, is accessed via the response provided by the Qlik.openApp method. The first thing we're going to build is a filter, which will show us a list of data from a particular field within our app and allow us to interact with it to make selections in the data. To get started, we provided a basic JavaScript class called List, which we'll use to keep everything together. The constructor accepts two parameters: element ID, which helps us identify where in our page to render the list, and options, which is an object, and at the moment expects a reference to the App API, or in other words, the connected Qlik app, and a definition property, which we'll talk about shortly. And we've added an event listener for the Qlik event. So now let's look at how we get the data from Qlik. To do this, we can use the Createlist method on the App API. The method requires two parameters. The first is an object, which should represent a QList object def struct, and in the case of our class, we'll refer to that definition property on the options parameter. The second parameter to be passed into the method should be a function. This function will be executed every time the state of the application changes. Given our class structure, we'll define a new method called render and use that as our callback, like this. When the function is called, Qlik essentially gives us the layout of the object, so we'll accept a single parameter, called layout. The Createlist method actually creates a generic object and returns a promise, which provides the model of that generic object, which means that we can now call any of the available methods that belong to it. We'll store a reference to the model on the class, like this, so that we can access it from any method within our class. When creating a new instance of our class and passing in a definition, or rather a QList object def, we can either refer to a master dimension and provide a QLibraryID property, or we can define an NX inline dimension def struct by adding a QDef property and providing the name of a field to the QFieldDefs array. We'll also add a QInitialDataFetch to ensure we receive some data back when the callback function is called. To render our list box, let's move to the render function in the class. In here, we'll get a reference to the QMatrix, which is where the data lives, by first checking to make sure that we have a page of data in the QList object.QDataPages property, and subsequently store the matrix in a variable to make it easier to access. Then we'll use a simple for loop to gradually build up an HTML string that contains each of the items within the list. The data in a QList object always returns a single column, so we can hard code the reference to that column as 0. As a reminder, each cell of data will give us 4 properties that represent the text and numeric values of the item, the selection state, and the unique identifier. We'll be using 3 of these 4 values in our HTML. First, we'll use the QText value as the inner HTML of each element. The QState value can be used to help us style the elements with CSS based on the value provided. We'll prefix this with the word state and add a second class of list item to make it more identifiable. Finally, we'll add a custom attribute to the element, which stores the QLM number. We'll be using this shortly to make selections on the data. If we now create a couple of new instances of our list class, we can see our lists rendered on the page. However, they aren't interactive yet. To finish the class, we can add some code to the handleClick method, which firstly checks the event parameter to see if the clicked element contains the list item class. If it does, we can use the HTML elements getAttribute method to get the value of the data_element attribute we added earlier, which, as we mentioned earlier, is the unique identifier of a given value in a field. As such, it's ideal to use for making selections. Making a selection on the data can be achieved by using the model of the generic object and calling the selectListObjectValues method, passing in the path of the Qlist object def, the array of values to select, and the desired toggle behavior. We mentioned earlier that the callback parameter provided when calling the Createlist method is executed every time there is a state change, which is exactly what will happen when the selectListObjectValues function is executed. So if we go back to our web page, we can click on the items in the lists, and with some CSS defined for each of those state values, we can see the list update to match the current selection state. Next, we'll be taking a look at how we can apply the same technique to hypercubes with the createCube function. But first, it's time to complete some activities.
You can stay up to date with all of our content by subscribing to our YouTube channel or following us on social media. If you'd like to see more from this course, then head over to websy.academy, where you'll find our full set of training courses complete with hands-on activities and much more.